Hello friends, myself R.D. Mahajan presenting my next video on MCQs on partial differentiation part 1. If u is equal to e raised to y by x, then dou u by dou x is equals to. Find the correct answer out of that 4 option. And to find that correct option, here given u is equal to e raised to y by x, it is required to differentiate u with respect to x, keeping y constant, and therefore here y is constant term. Derivative of e raised to ax is e raised to x into a. It is e raised to y by x. Applying chain rule, differentiation of 1 by x with respect to x is 1 by x square with minus sign. Therefore, it is minus y by x square. We are taking y as constant term as outside. Therefore, it becomes minus y by x square into e raised to y by x as the answer. Option B is the correct option. Second example, if u is equal to x raised to y, then find dou u by dou x. Then value of dou u by dou x is equals to. Therefore, to find the correct option out of that 4, here given u is equal to x raised to y, a function of two independent variables x and y, and we require to differentiate u with respect to x, keeping y constant. Therefore, here it is y constant term. It is, we know that derivative of x raised to n is n x raised to n minus 1. Applying that property or rule here, its derivative with respect to x is n means here y, x raised to y minus 1 as the answer, and it is option D as the correct option. Example number 3, if f of xy is equal to 0 is an implicit function, then dy by dx is equals to. We have to obtain the correct option out of that 4, and for that we use the definition of total derivative. Here f is a function of two independent variable x and y are function of a third variable t. Then by this tree diagram we have df by dt as differentiating f with respect to x, and that is partial derivative dou f by dou x. Chain rule, differentiation of x with respect to t as dx by dt, plus differentiating f with respect to y, partial derivative, and derivative of y with respect to t. This result is called as the total differentiation of f with respect to t. Then we can cancel dt throughout. We get therefore df is equals to, total derivative of f is equals to dou f by dou x into dx and dou f by dou y into dy. And if f is an implicit function, means if f is equal to 0, then that df derivative of that function is 0. We get df is equals to 0, and that is equals to dou f by dou x into dx plus dou f by dou y into dy. Then rearranging it for dy by dx, transferring this to other side, we get dou f by dou y into dy is equal to minus dou f by dou x into dx. Transferring this to left and this to right, we get therefore dy by dx as minus dou f by dou x divided by dou f by dou y. And that is nothing but another notation we can use for dou f by dou x is fx suffix x, and dou f by dou y means suffix y. Therefore this is the value of that dy by dx. Therefore whenever that function is an implicit relation, dy by dx is given by minus fx divided by as the correct option. Example number 4. If u is equal to x cube plus y cube divided by x minus y is a homogeneous function of degree n is equals to, and therefore here we require to find the degree of that homogeneous function, and to find, given u is equal to x cube plus y cube divided by x minus y is a homogeneous function in x and y, and to determine the degree we have to convert it into its general form by taking x common from both numerator and denominator. Therefore we get, taking x cube common from numerator, we get 1 plus y cube divided by x cube, and whole divided by, taking x common from the denominator, we get 1 minus y upon x, and this is nothing but x cube divided by x, we get x square, and the remaining terms are terms of y by x. Therefore it is function of y by x. Therefore this is the general form of that homogeneous function x raised to n into f of y by x, and it implies therefore the degree of homogeneous function is the power of this x, and therefore here power is 2. Therefore we get degree as 2 as the answer. Option B is the correct option out of that 4. Example number 5. If u is equal to log of x square plus y square plus xy, then the x dou u by dou x plus y dou u by dou y is equals to. This type of term means it is a problem of Euler's theorem on homogeneous function. If it is a homogeneous function, and we check whether it is homogeneous or not, given u is equal to log of x square plus y square plus xy, it is function of function, case number 2 for Euler's theorem. Degree of x is 2, degree of second term is 2, and degree of third term is 2. Therefore as degree of each and every term is same, it is an homogeneous function, and therefore transferring this to other side, we get e raised to u is equal to x square plus y square plus xy. We call this as function of u as e raised to u. Differentiating it with respect to u, we get f dash of u as e raised to u, and to determine the degree, we consider that expression on the right hand side, and then rewriting it by taking x common from all this term. Therefore taking x square common, we get 1 plus y square by x square plus y, it is x by y, it is x square some function of y by x, the remaining terms, a general form of any homogeneous function, and then comparing with that general form, we get therefore n is equals to power of this term. Then substituting all that values in Euler's theorem, by Euler's theorem we have x dou u by dou x plus y dou u by dou y is equals to, as it is second case, the result is n f of u by f dash of u, and therefore it is equals to, the value of n is here 2, f of u is e raised to u, f dash of is also e raised to u. E raised to u get cancelled, and therefore value we get as 2. Therefore, after that 4 option D is the correct option. Example number 6. If u is equal to x raised to y, function of two independent variable x and y, then dou u by dou y equals to. To obtain that dou u by dou y, we have to consider x as constant. Given u is equal to x raised to y, differentiating it with respect to y, keeping x constant. Therefore, it is somewhat similar to d by dx of a raised to x. With a is constant, here x is constant, therefore we can use this result. The differentiation of that a raised to x is a raised to x into log of a. Therefore, we can use this rule to find the partial derivative of u with respect to y by keeping x constant. Therefore, here it is a raised to x means x raised to y into log of a. Log of a means log of x as the answer. Option A is the correct option. Example number 7. If u is equal to tan inverse of x square plus y square divided by x plus y, then by Euler's theorem, x dou u by dou x plus y dou u by dou y is equals to, we have to obtain the answer for this. And as here it is mentioned that it is Euler's theorem we have to apply. We check whether it is type 1 or type 2, or case 1 or case 2. Here u is a function of tan inverse, and tan inverse is again function of x and y, means it is function of function, and as it is function of function, it is case 2 or type 2 for Euler's theorem. And therefore, given u is equal to tan inverse of x square plus y square divided by x plus y, then transferring this to left side, we get therefore tan of u is equal to x square plus y square divided by x plus y. This we consider as f of u, function of u, as tan u. Then differentiating it with respect to u, we get f dash of u. Derivative of tan is secant square u. Then try to find the degree of that homogeneous function. For that we consider that x square plus y square divided by x plus y. Taking x common from both numerator and denominator, x square common, we get 1 plus y square by x square. Taking x common from denominator, we get 1 plus y by x. Simplifying it, one x get cancelled, therefore we get x remaining, and the remaining terms are function of y by x as 1 nothing but y by x is to 0. Therefore, every term in the form of y by x, and therefore, in short, we can call it as function of y by x. It implies n is the power of that x, and here that power is 1, and therefore we get the value of n as 1. And then by Euler's theorem, we get x dou u by dou x, it is first order derivative, y dou u by dou y, and as it is case 2 or type 2 problem, the result on right hand side is n f of u by f dash of u. Or type 1, for type 1 it is only nu. It is not type 1, it is type 2, and therefore right hand side must be n f of u by f dash of u. And then substituting the values, we get it is equals to, the value of n is 1, f of u is tan u, and f dash of u is secant square u. And then rewriting it, we get tan nothing but sine by cos, and 1 by secant square nothing but cos square. One cos get cancelled, we get it is sin u into cos u. In the required form or required option, we multiply it by 2 and divide by 2, so that we get the required form. All of we know that 2 sin theta cos theta is nothing but sine of 2 theta, and therefore it is sine of 2u as the answer, and therefore x dou u by dou x plus y dou u by dou y is equal to 1 by 2 sine of 2u. It is option B as the correct option out of that 4. Example number 8, if u is equal to x raised to n into f of y by x as a homogeneous function in x and y, it is the general form of that homogeneous function with degree n, then by Euler's theorem we have, and therefore here given function is u is equal to x raised to n into some function of y by x as a homogeneous function in x and y with degree n. Then by Euler's theorem, there are two cases for Euler's theorem. Case 1, when it is simply function of x and y, and case 2, when it is function of function. Here we have a function of xy only, therefore it is a case 1, and for case 1 statement of that Euler's theorem is x dou u by dou x plus y dou u by dou y is equals to n into u, where n is the degree of homogeneous function. Therefore this is the required answer. It is option C as the correct option out of that 4. Example number 9, if dou z by dou u is equals to dou z by dou x plus dou z by dou y, then dou by dou u is equals to given dou z by dou u is equals to dou z by dou x plus dou z by dou y. This we can rewrite in terms of operator. Dou z by dou u I can write as dou by dou u operated on z it is equals to dou z by dou x we can write down as dou by dou x operated on z, and dou z by dou y we can write dou by dou y operated on z. And as all the operators are operated on z, we can cancel that z throughout. It implies dou by dou u operator, dou by dou u is equals to z get cancelled, we get dou by dou x plus dou by dou y as the answer, and it is option B as the correct option out of that 4. Last example, if z is function of x and y with x is equal to u plus v and y is equal to uv, then find the value of dou z by dou u. Therefore, here z is function of two independent variable x and y, and this x and y are again a function of another two independent variable u and v, means it becomes a function of function. And whenever we have such type of tree diagram, it is the problem of change of independent variable, and therefore to find the value of dou z by dou u, we can differentiate this z with respect to u, but it is not directly function of u. Therefore, to find the partial derivative of z with respect to u, directly we are not getting it. We have to differentiate z first with respect to x and then x with respect to u, as it is function of function, applying chain rule, and therefore it is dou z by dou x chain rule, differentiation of x with respect to u plus differentiate that z with respect to y and then again y with respect to u, and therefore dou z by dou y into dou y by dou u. All the derivatives are partial as it is function of more than one independent variable, and then performing that partial derivatives we get dou z by dou x we keep as it is, differentiating x with respect to u keeping v constant, therefore derivative of u with respect to u is 1, differentiation of v is 0, plus dou z by dou y as it is, no change, and differentiation of y with respect to u keeping v constant, therefore applying that product rule, we take outside as it is constant, and differentiation of u with respect to u is 1, and therefore we get v into dou z by dou y as the value for dou z by dou u as the required answer. It is option B. I will discuss in my next part for this MCQs on partial differentiation. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel to get new updates or a notification for new videos. Thank you very much.